Our word problem states the height of a piston in a cylinder can be modeled by a sine or cosine function. A piston is at its lowest point in a cylinder, 8 centimeters from the bottom at 3.2 seconds. The piston is at its highest position, 39 centimeters from the bottom at 3.6 seconds. Find an equation for the height of the piston in centimeters at any given time, which is t. The given information includes that when the piston is at 8 centimeters, it is at 3.2 seconds. And when the piston is at 39 centimeters, it is at 3.6 seconds. Using the information given, our task is to find a sinusoidal equation that represents what the word problem is explaining. The given information helped us find that our equation is actually y equals negative 15.5 cosine times 5 pi over 2 plus 23.5. So the problem tells us that the minimum height will be 8 centimeters. The maximum height will be 39 centimeters. The height difference between the two is found by subtraction, and once we have that, we can divide by 2 to find the midline and therefore find the amplitude. So we now know that the amplitude is 15.5. Since the minimum is 8, we added that to the location of the midline. So we found that the vertical shift is 23.5. The difference in the two times given is 0.4 seconds, which represents a half of a cycle. So that means that one cycle would equal 0.8 seconds. By using that, we can find the angular frequency by plugging 0.8 seconds into the formula P equals 2 pi over B. With that, we know the angular frequency is 5 pi over 2. There is no horizontal shift, and we also know from the equation, because negative 15.5 cosine is a negative graph, we know that our graph should be a negative cosine graph.
Our essential questions are: find the height of the piston 15 seconds after the engine has started. So to answer the question, we use the graphing calculator with tracing capabilities to determine where the y position would be at 15x, since that would be the time. So we go to 15 exactly in the x-axis, which is right here, and we find that our y position is 23.5. So that answers our question, saying that it is 23.5 centimeters above the ground. That brings us to our next question, which is: find the first time the piston is 13 centimeters from the bottom. So, once again, we use the graphing calculator with our equation input to go to y is equal to 13 on the calculator. So we just trace slowly until we get to y is equal to 13. 13.7, so we got a little lower. 13.25, 12.89. So we're going to get as close as we can as 13. 13. 13.5, 13.4, 13.3, 13. And so here we can determine that the first time that the piston will be at 13 centimeters above the ground is at 0.106 seconds, as we can see from our x-axis. That'll answer our essential question number 2. 13.06 seconds. So now to graph the equation by hand, we will use the different hints in the equation. So we see here that 23.5 is where the midline will be. So we go here, 23, as far as accurate as I can make it, 0.5. We draw a dotted line for the midline, and that will be our midline. So since it's a negative cosine graph, we start at the minimum, which we know is 8. And by using the amplitude, which is 15.5, we go 15.5 above the midline. We must also find the period of the equation by using the frequency to help determine how often the curves will be on the graph. So the period equation is 2 pi over b. So we know that b is 0.8 because the problem says that it takes 0.8 seconds to go from lowest to bottom and high again, which would be 1 period. So by using 2 pi is equal to 0.8, we know that for 2 pi to be 1 cycle, it would take 0.8 seconds. So we do 0.8, which would be about here on the graph, and that is where it would reach this is where it would reach the minimum value again. So at 0.4, which would be right here on the graph, it would reach its maximum value. And at 0.2, which would be right here, we'll reach the midline. And at 0.6, which would be around here, we'll reach the midline again. And we just replicate this once again. So we go to another 0.8, which would be here, and this would be the starting point. We go to another 0.4, which would be halfway between these two, and it's another maximum point. 2 more midline points, and we have a hand-drawn piston equation graph. Now to clarify one more time, because many people might get confused on this period simply means that it takes 0.8, let me erase this, 0.8 seconds for the entire graph to complete 1 cycle. And you know it's 1 cycle because it's 2 pi. In our raw equation, it would be 5. Since it's 5 pi over 2, this is simply saying that it takes 2 seconds for the cycle to complete itself 2.5 times. 2 pi plus 2 pi is equal to 4 pi plus 1 pi, which is half a cycle, being 1 pi, since it's not 2 pi, 5 pi.